Hello everyone, I'm Jianhong from Renmin University of China. In this talk, I will present RPT, Relational Pre-trained Transformer is almost all you need towards democratizing data preparation. Data prep is time-consuming and machine-hard. According to expert estimates, data scientists spend from 50% to 80% of their time to collecting and preparing data before it can be explored for useful nuggets. First of all, I will present a data cleaning scenario to help us understand typical data prep problems. Here shows a table with some missing values. Table 2 asks for the city of the Michael Jordan. This question can be answered according to Table 1 if one knows that machine learning belongs to computer science and NIST is equal to nice street. Table 3 asks the last name of someone. Obviously, one can fill Jordan with the prior knowledge that Michael Jordan is a basketball player from New York City. In reality, there are many other problems. We find that domain knowledge is very important in cleaning this table. These problems are easy to solve for human, but it's hard for machine to obtain this knowledge. In order to make computer get enough knowledge to solve the problems, there have been many existing studies. We categorize them into 3 types. Here, take data cleaning as an example. The task is to detect and repair data errors in D. The first direction is to only examine D, such as supervised machine learning. This method needs enough signals or data redundancy from D and learn only from D without external knowledge, which cannot be generalized to other datasets. In order to connecting with external knowledge, researchers have used explicit knowledge, such as master data and knowledge bases. In reality, external source cannot provide completely information, and it still needs a lot of manual participation. In practice, a lot of human efforts is to search the data in the wild, such as enterprise tables or web pages. Human can read and comprehend this knowledge and manually clean D, which is useful but time-consuming. Hence, our proposal is mainly to make machine learn and remember the knowledge in the wild, so as to reduce human efforts and achieve near-human intelligence. To achieve our goal, we need to design a model that can best imitate human learning ability. Recent evidence from the NLP community, where deep learning-based models and representations have been shown to perform nearly as well as humans on various language understanding tasks. Represented by GPT-3, it has strong learning ability and can be used to code, write, and have a conversation automatically, which suggests that GPT-3 may be a viable option for our data prep tasks as well. Recall that our task is to clean a relational data. If GPT-3 is directly applied to relational data, there will be some problems because GPT-3 is suitable for text sequences. However, relational data has big difference with text. For example, the attribute value and attribute name are closely related and play a decisive role in each other. Unlike sequence semantics, relational data has special set semantics. The order of different columns will not affect the semantics of each tuple. Because of these characteristics, we need to train a relation-aware model, different from GPT-3, which uses text corpora and next token task for pre-training. We use table corpora to pre-train the model and design a new pre-training task that is suitable for relational data. Naturally, we use massive relational data as our corpora to pre-train the model, such as web tables. Because these corpora can provide relation-aware semantics. We use deep learning-based architecture with transformer. The transformer architecture can use self-attention to get the relationships between attribute name and attribute value, or relationships between columns. After selecting data and model, we propose a self-supervised pre-training task, which can teach the model some prior knowledge without any human labels. More specifically, here, we introduce RPT. We use a transformer-based sequence-to-sequence architecture like BERT, which is a generation of both BERT and GPT-3. The architecture contains a bidirectional transformer-based encoder and a left-to-right autoregressive decoder, because it has the advantage of learning to predict the corrupted data bidirectionally. Because most relational data prep tasks are based on tuple, we design a tuple-by-tuple training mode. We represent each tuple as a concatenation of its attribute names and values, and add special tokens A before an attribute name and V before an attribute value. And we add a special column embedding to represent different columns, so we can get a sequence of tuple with a richer tuple-aware semantics. We design a pre-training task to guess a missing attribute name or value. The training objective is to corrupt tuples and then optimize a reconstruction loss. Given an input sequence of a tuple with some value to be masked out, represented by a mask token, the bidirectional encoder will look at the information before and after the masked token, learn which token to pay attention to, and generate an intermediate vector H. The autoregressive decoder will take H as input and generate an output sequence. By denoising the masked input to be machine learning in this example. Different from BERT, RPT can predict multi-tokens of one single masked token with text infilling technology. Here, we show our preliminary experiments to show that RPT can reconstruct the masked tokens in tuples. The baseline is BERT, which is pre-trained on text corpora. We use product datasets ABTBuy and Walmart Amazon to pre-train RPT and report the results on another product dataset, Amazon Google. We masked attribute values and asked BERT and RPT to predict the original values. This table shows some results, where M means that the value is masked out. These results show that RPT pre-trained on tables can learn structural data values from tables better than directly using a pre-trained language model. The main reason is that by pre-training on the product tables, RPT can better learn the domain knowledge, and thus is more capable of predicting missing values. The RPT with tuple-to-tuple pre-training can be directly used for several common data prep tasks, such as error detection, data repairing, auto-completion, and auto-suggestion. Moreover, the architecture of RPT provides the flexibility to be fine-tuned for different downstream tasks. That is, tuple-to-X. X could be tuple, token, label, JSON, and so on. Take information extraction as an example. Given a tuple, it extracts a span or multiple spans of relevant text, which can be done by fine-tuning the decoder to produce the start and end pairs of spans. Here, X represents tokens. Due to time constraints, more details can be found in the paper. In this talk, we present some typical data prep problems and propose RPT, which is promising to automate many data prep tasks. Next, we will focus on better handle set semantics of relational data, study column-based and table-based learning tasks, and improve the availability and quality of benchmarks for pre-training tasks. That's all. Thank you for listening.